Before we start with the panel, I first wanted to introduce the panel. We are going to start this conference with this first panel, which is called State of the Art of AHP and ANP in the Light of Artificial Intelligence. The chair of the panel is going to be Alessio Ishizaka. Alessio is a distinguished professor at the Neoma Business School. He was head of the Information Systems, Supply Chain, and Decision-Making Department. He was also research lead and deputy director of the Center of Operational Research and Logistics at the University of Portsmouth. Alessio has also received his PhD from the University of Basel in Switzerland. He worked successively for the University of Exeter, United Kingdom, York, United Kingdom, and Audiencia Grande, École de Management, Nantes, France. He has been visiting professor in several universities in Italy, France, and Germany. His research is in the area of decision analysis, where he has published more than 160 papers. He is regularly involved in large European funded projects. He has been the chair, co-organizer, and guest speaker of several conferences of this topic, especially the International Conference of MCDA 2022. He is associate editor for Omega, Expert Systems with Applications, and Journal of Knowledge Management. He wrote the indispensable textbooks, Multi-Criteria Decision Analysis Methods and Software, and Multi-Criteria Decision-Making Sorting Methods. I leave you with Alessio and his panel. Thank you very much.
Thank you, Monica. Today we are speaking about AHP and artificial intelligence. Artificial intelligence, now everybody speak about it. We will have a panel to have a debate about artificial intelligence and AHP. The panel is composed about with Elena Rokou, Marcel Minutolo, and Ashraf Labib. For me, artificial intelligence is not really new. When I was at university, we already were studying artificial intelligence with neural network, with logic, with expert systems. Simply today, it has taken a larger proportion, mainly because the machines are becoming much powerful. They can do more. There is as well internet, who has democratized artificial intelligence. Is it artificial intelligence competing with AHP? I think no. Because, well, artificial intelligence cannot know our preferences. We know what is particular in AHP, it is subjective. Some people don't like it. They say they are the core optimization. They are doing core optimization, where they want everything very objective. But we cannot deny that our world is subjective. Everybody has different preferences. And this, an artificial intelligence cannot guess what is the preferences of everybody. So our decision is still very individual. Artificial intelligence can inform, can give us information, but will not take decision for us. It will give some information that will help us to find some criteria, will help us to evaluate some judgment, but at the end, the decision is ours. An artificial intelligence will not be able to find a solution for strategic problem. It can find solution for repetitive problem, but strategic problem, I don't believe it. Now I will give the floor to my colleague, to just expose what I think, and then we will discuss, debate about it. Elena, do you want to give your point of view?
Sure, why not? Thank you, Alessio. Actually, I couldn't agree more with you, but I'm coming here to add up a little bit to that. AI is pretty much everywhere right now. However, it comes to a point that you will be asking, everything that we get from AI should be accepted as is. How can we create ensuring mechanisms to help us in the process of validating and having a more balanced AI system? Actually, although some of you might not believe it at the beginning, I come from the software engineering side, and I'm always prone to believe and love everything technological and any technological advancement. However, the truth is that AI, as transformative is, that much prone to bias is also. And bias arises from data, algorithms that we use, systemic inequalities. And the thing is that structured decision-making models like AHP and ANP can help identify, analyze, and mitigate bias in the process. So the idea is that sometimes there is unfairness in AI predictions. It might come from historical biases in data, misaligned objectives in the model design. It can come from lack of diverse perspectives in the AI training. And here we have a huge opportunity, create decision-making systems that support and balance out this unfairness, because only human judgment can bring back this unfairness and identify the issues that are coming across from this kind of biases. You see problems, for example, algorithms that use race as a proxy for biological differences, leading to medical and health support systems that are not 100% unbiased. Quite the opposite. There is explicit equity metrics that could be used as decision criteria, HP decision criteria, to improve that situation, just to talk about an idea or two. Or even models that perform poorly because the training data underrepresent specific parts of the population. And what about AHP? Why I'm talking in an AHP ANP conference about this? Because you can use AHP to prioritize data, augmentation, and equitable sampling. So the bottom line here is that there are a lot of different perspectives when you use AI. However, everybody agrees that there is a level of bias in most of the AI systems. And here I come to say that we need to integrate decision-making frameworks into AI. We are not competitors here. We need to collaborate in order to ensure fair and systems that provide fairness and equity to everybody. Since AI brings the technological advancement and the strength of analyzing data very quickly and making the correlations that are needed to make, while HP&P brings the human side of this equation. Personal judgment, perspective, bringing back fairness, bringing back the ability to adjust objectives using stakeholder-defined criteria, the thing that HP&P is known for. And that's kind of the ethical dilemmas that we end up that HP could help. Accuracy versus fairness, inclusivity, how to amplify underrepresented voices in the development using decision-making, or accountability. Who is responsible for biased outcomes? We cannot only help for making more balanced and fair systems, but help decide who is responsible for what in the overall line. And that would be kind of my perspective on what our future about AHP, decision making, and AI.
Thank you, Elena. I would now give the word to Marcel.
Thank you, Alessio. So as I was reflecting on the comments that I wanted to make for this morning's panel discussion, I was reminded of a recent Institutional Review Board committee meeting that I was having, the IRB. I'm sure many of you are familiar with going through these. And the IRB that I'm co-chair of wanted to add a question onto our application about the use of artificial intelligence in the research that faculty were doing, which I was opposed to. And one of my colleagues says we need to add this on because AI is new and we're trying to get our hands around it. And I'd like to remind everybody that AI really is not new. It's been around for a long time and we've been using it in our everyday lives, from everything from our spell checkers to spam filters to search engine algorithms. We've been using AI a lot. And it's an extremely large discipline. And right now, when folks are talking about AI, most people are referring to the large language models, LLMs. And they're forgetting about all the algorithms, the decision support systems, the simple statistical functions that are being used, which are part of our AI applications. My first AHP conference, I'm going to date myself a little bit here, some 20 years ago, was the result of my presenting to a battalion commander in a combat zone the use of AHP in helping decision making. And he responded to me that I would take away his decision making authority. And my response to this battalion commander as a young lieutenant was, no, I'm not trying to take away your decision-making authority because ultimately he's responsible for putting people in harm's way. What I'm trying to do is improve his decision-making capabilities because there's such a large volume of information coming in. Shortly thereafter, my dear friend and mentor, Luis Vargas, and I wrote a proposal for DARPA to try to apply AHP with artificial intelligence to improve the prioritization of the allocation of resources in a battle space. We did not get the funding, unfortunately, but it was still a good proposal. Here we come 20 years later, and our machines are much more powerful than they used to be and much more capable. Our algorithms are better. And we're able then to feed information near real time coming in from the Internet of Things, our IoT, to prioritize the allocation of finite resources that we have in ways that more efficiently produce whatever it is we're trying to do from an organizational perspective. And we can do this, and we're finding out how to do this better using language to get some kind of intensity of preferences for where we want to put our resources. I will caution folks as we're finding out that right now, most of these LLMs are still infants. They're not thinking so much as they're regurgitating. And so right now, we have to use all of these LLMs tentatively, but it's getting better. And we can use APIs to just stream information into whatever the models are that we're building from an AHP or ANP perspective. Alessio, I turn it back over to you.
Thank you, Marcel, for your view. Ashraf, it's your turn.
Okay, thank you, Alessio, very much. I'm going to divide my my small talk into three aspects: AHP, ANP, in terms of problem structuring. Can AI play a role? Yes or no? And then what makes the judgment? Can AI, or who makes the judgment? Sorry, can AI again play a role in who makes the judgment? And then finally, in terms of a higher level, which is the choice of the objective of the decision or the method itself which we're going to use. Can AI also play a role? So let me start by the first point, which is about problem structuring. If you allow me, I can just give a little bit of background where I come from. When I did my PhD, at the beginning of my PhD, I was exploring using artificial neural networks in making into AHP to look at incomplete hierarchies. And I was going to attend the conference. This was back in 1992. So I sent an email to Tom Saad, and I told him I'm going to speak about this in the conference. Would it be any chance I can pass by Pittsburgh to see you? And he sent me a very nice email back, said, yes, please come and stay with me and Roseanne, and it would be nice to host you and to see you. And he actually waited for me in the airport. So I was really impressed with him. And then while I was there, he told me something very, I think I took it during my life, that the most important thing in AHP is problem structuring. Everything else can be automated, but problem structuring really is the key. If you can build a good hierarchy, good model, you solve most of the problem. And I think in a way he was saying what back in 1938, Einstein and Einstein wrote a paper when they said that when you structure the problem, you solve the majority of 90% of the problem. So I think, and this is something that I so this is really, yes, this is something that is quite interesting. And at that time, the people, obviously the influential people who work in this area of incomplete hierarchies were people like Vargas and Harker on incomplete judgments and so on. And also, I think, reflecting on this concept, I think that also there was some work on the hierarchical, which is like a database of all the PhD models divided by different disciplines. So I think in the future, maybe in the future, the AI can contribute to problem structuring, whether it can look at it in different contexts. So people can, for example, working in a certain area, they can see all the what has been structured in the past in that area or that discipline, and maybe there is. But I think the generative AI, as we know it now, has not done this yet, but maybe in the future, there is room for improvement in that sort of area. Going back to my second point, which was who makes the judgment? Can AI play a role in that? I came across a very nice book, which I highly recommend, by Jean Tirole, who got Nobel Prize in economics. He's from University of Toulouse and MIT. And I had the chance to meet with him 2 months ago in a conference. So I started to read this book 2 months ago. And I want to quote something from his book verbatim, really, because I thought that he wrote it in a very nice way. He was speaking about the future in terms of cars and who's making the decision. So he was saying that consider another example, an example where in the future cars are going to be driverless, which are currently actually this is what we are facing now. And accidents could be reduced by 90%. Our streets and road will be much safer. So this is what people are aspiring to and think this is what will happen due to AI. But our societies will have to make morally sensitive choices. Suppose that I'm driving my car alone and I find myself in a rare situation in which I cannot avoid an accident. My choice is limited by 2 options: sacrificing myself by steering into the ditch, if I'm going to sacrifice myself, or killing 5 pedestrians who are on the road. Today, the driver makes this decision. So in this case, in a split of a second, whether you sacrifice yourself or whether you kill the people. Tomorrow it will be an algorithm installed in the car, programmed in advance to react dispassionately to this situation. So in the future, the algorithm will make the choice one way or another. So would you prefer to buy a car that sacrifices its driver, in this case you, or would you rather buy the model which killed the which killed the pedestrians? Intuitively, I would perceive the first car as more moral, because obviously you are sacrificing yourself. But if this is your decision, so on probability, the chance is that you will be actually one of the pedestrians. You are more likely to be one of the pedestrians than this driver. So it is this sort of decisions at a very highly moral level, which I think what the humanity is going to face, which is who makes the decision. And I think, to my knowledge, it's difficult to find answer to such a question, such a moral question. And whether AI can help in that, in terms of making the judgments, I'm not sure. But I attended one of AHP conferences many years ago, one of the earliest ones that I attended. That was back in the late 90s, or mid 90s actually. And I saw some paper where I think it was Hamarinian who was doing it. He was judging, for example, mobile phones by accessing the mobile phone data from the vendor of that mobile phone kind that you are judging. And in doing that, it can help people to make judgment based on the data that exists on the web. So I think generative AI can maybe help in doing that by looking at giving you some indications. And I think this could be very useful. Then comes the choice of the model. The choice of the model, I think, about which is a very high level. Who is doing the, are you using the right method? There is something called single loop, double loop learning, which is from Agregas and so on and so on. But there is what's called triple loop learning, which is, are we solving the right problem rather than are we using the right methods to make the problem? So, or are we using the right methods? Should we use something else other than AHP and NP? Should we actually be solving that particular problem or another problem? So this is looking at the epics of the AHP model. Are we considering the right problem in the first place? For example, does being right means being consistent in your judgment? All this sort of question, I think AI is still far from doing it. So the choice of the method, I think still AI, maybe there are room for improvements in this area. So just to summarize, I was looking at the problem structuring, who is doing the decision and how do we give them weights. Alessio and I have done some work on giving weights to the decision makers and so on, but there is room to do that in different ways. And also, are we actually solving the right problem? Thank you very much. Over to you, Alessio.
Thank you, Ashraf. You start really to give some way to research for the future, Ashraf. I would like to ask Marcel, you said AI was long time and you see the evolution. Do you think the evolution will be about AI being to take decision alone for us, right decision for us?
I'm sorry, Alessio, was that a question for me?
Do you think artificial intelligence will be able to take decision at our place and taking the right decisions?
Well, actually, that's a great question. And if I can build on what the analogy that Ashraf just gave with the autonomous vehicles, this is often referred to as the trolley car problem. And in philosophy, we've been dealing with this for a very long time. And AI is good at making decisions already, but the reason why we're not doing it is because we can't agree on the ethical decision framework. Do we use a utilitarian framework to evaluate our decisions? Do we use a teleological framework to evaluate our decisions, or perhaps even a deontological framework? So until we can agree on the ethical framework that we're using to make our decisions, I don't think that we're going to agree that AI can make the decisions for us. And we're far from that. Structuring the problem and how we structure the problem is something that we haven't been able to agree upon as society yet. So I think we're far from there. But having said that, I think we're at a point where we can have AI inform our decision makings, not make the decision for us. And we can provide input to the hierarchy that facilitates AI helping inform our decision making. And I think we're pretty close to that, and it's doing a good job right now.
Okay, Marcel. I want to touch the problem of group decision, because in AHP as well we have group decision, and today in company decision are taken by group. I read some article on psychology where they do survey, and they do survey as well with an artificial intelligence, and it's matching more or less what a sample of population will answer and what an artificial intelligence will answer. Do you think, I will ask Elena, because I know you work in group decision as well, an artificial intelligence will able to help a group to take a decision, not a person, but a group this time?
That's very, very interesting, Alessio. I hadn't thought about it from that perspective, but I think that it's probably the only way that we can see AI participating. But the only perspective that I would add to that is what about training for the perspective of a specific group and organization, AI, specifically for our perspective, giving a little bit of our experience and kind of our moral compass that might not be fully acceptable or fully standardized before letting the AI do the group decision making in our place. Meaning, what about creating a full training set whenever you add people in a C-suite position in order to kind of acquire their perspective on a lot of matters, and from that point on, start using the AI supported group decision as, let's say, a 90-10 rule, meaning 90% of the information and the judgments come from the AI directly, 10% of validation comes from the actual people, making it very fast, but still the accountability stays with the people that are deciding in the group.
Thank you for your answer. There is some danger as well from artificial intelligence. We know that, well, we can have robots, killer robots, that, well, we train them and they will kill everything that moves. How we can prevent it? Ashraf, you have a background of engineering. How we can prevent having killer robot in our planet?
I think when we look at safety and the risk using the bow tie sort of method, you have barriers that we can do to prevent things and things which we can do to mitigate after things happen previously. So I think prevention. It depends on how well we test the algorithms in different conditions, and as was said earlier on by one of the speakers, that what extent do we generalize the training data and the AI and stuff like that. When it comes to mitigation, I think the problem comes again to the ethical, when the whoever doing the algorithm, and then you have an accident, the car accident or whatever. Who do you blame? Do you blame the manufacturer? Do you blame the condition? Or who do you blame? And who, not just who do you blame, and how do you prove? And the ethical issue, I think, is a thing which is still not answered. As again, one of the speakers confirmed that as well, the previous speaker. So I think it is really. I don't really have an answer, but I think the thinking should be, how do you mitigate after the accident, and how do you prevent, and also how do you improve the in the risk priority number. It has 3 elements. It has frequency, which is you are preventing it happening in the first place. You have the severity, which is the detection, and then you have the detection. So how do you improve the detection capability? So maybe the R&D should focus more on the detection capability to make it as fast as possible. So I think that's the 3 elements of what define risk: occurrence, severity, and detection. I suppose which the work should be done. Sorry, my answer was vague.
I still was hoping, Ashraf, that you would say that we will implement the 3 laws of robotics from Ishizaka.
Yes, from some of yeah. But they are implemented, I suppose, in the robots. But I know one of my colleagues who was actually he works as an ethics professor, working with people who are in the army, in the aviation, who are controlling, the drones to kill people and so on. And these people will be psychologically disturbed after a day job. So. What he's saying, that they were thinking in the defense, in the army, in the British Army, that like a thought experiment. Suppose that the robot or the drone is programmed to kill the enemy, and every time the robot is going to shoot at the enemy, the operator who's running who's from the army is saying, no, don't do that. Don't shoot. And then he tried again to do that, and then said, no, don't shoot. So eventually, because the objective function is to kill the enemy, it might be the case that the robot will turn around, or the machine, and kill the operator, because it's affecting it, performing its objective. Its final objective is to kill. So I think this is the dangers that we are now moving toward the area where we are giving the machine not just to be efficient in the decision making, but if we move towards making the decision, then we are always playing with fire.
Marcel, do you think artificial intelligence can become ethical as well? Like Ashraf said, the machine is trying to kill, so can it learn as well not to kill if it is become unethical?
Yeah, I actually I love Ashraf's example here of the drone and setting the goal to kill. Right. This is largely a function of how we structure the hierarchy. If we define the goal as killing, then the drone will seek to optimize the killing function. So we need to structure the hierarchy in such a way that the goal isn't necessarily to kill, but perhaps to increase the overall utility of life. And then whatever criteria we're setting to define that objective function, that we then have to train the machines on how we value those criteria. So if we set the criteria then to be maximizing life, minimizing death, improving overall quality of living, and whatever other criteria we set for that, and we tell the drone not to kill in certain instances, what we're then doing is reinforcing the learning that the drone is doing to seek how we are prioritizing the actions that the drone is taking. And so again, this is going back to what Ashraf was saying earlier about the double loop learning, right? We're reinforcing the learning process that the drone is building upon. This goes back to my point that I was making earlier. The velocity at which information is coming in and the volume of information coming in is so great right now that, in my opinion, I think AHP can be used to help streamline our decision-making processes, assuming that we do a good job in building the hierarchy. But as Elena pointed out earlier, these hierarchies are only as good as the people who are building them. And unfortunately, we build bias into our hierarchies like we do anything else in life. So I think we need to reevaluate our models from time to time to make sure that they are addressing the goals that we think we're setting up for AI to be applied to. I hope that answered the question, Alessio.
Marcel, I'm sorry, Alessio, just for a second, but I'm wondering, as we are talking all together, is it even fair to expect that the AI systems will be better than the human decision makers that are generating them? I mean, we are talking about fair decision. I talked about unbiased systems, but we are designing the systems and we are biased. So is it correct to expect that the car will make the in quotes, right decision when I might not save the people, especially if my little baby is in the back seat, I might not go for it. I'm not proud. It won't be moral, but still I might not do it. And it's human, not moral, but human at that point, right?
That's absolutely correct. And this is why we don't have vehicles driving by themselves all the time already, because we have to program the machine to, one, make a decision based off of expected monetary value of a given life, two, life expectancy, three, overall utility, and we can't agree on these things. So when we build the model, we're prioritizing the decision making that AI is applying to whatever ethical framework that we're building out. And that's why we can't agree to have the cars making the decisions for us yet, or the drones. Sorry, Ashraf, please.
Oh, no, sorry. I just want to mention something that I think we are also still in probably phase 1 or phase 2 of the maturity level in terms of understanding or utilizing AI. So we can get we can live fine. We can get used to someone being a little bit biased, or we are biased, and we consider this as part of the human nature. But we still, at this stage, cannot accept that the machine is biased. But every one of us is biased in some way or another, and there is inherent bias as part of our human nature. But we still don't accept that the machine can be biased. And I think in the future, when we start to mature in our relationship with AI and understand better their capabilities and limitations, we will probably have better appreciation that they can be biased and use it as this is how life is, and try to improve. Thank you.
Thank you, Ashraf. I would like now to open the floor to the audience if they have question or remark.
Yeah, I like to make that issue of bias. That I participated in a project, to insert the use of AI in multiple decision making classes, in particular for the structuring part, because you're right that the student, the hardest part to learn is the structuring. What is the right question to ask, the decision to make, and what is the proper criteria. And in this we'll call it experiment, but the students were given the option of using AI to structure the AHP hierarchy, and then to compare it with the ones they had done. And the students, what they liked was, they said, one is very fast. It's faster than doing literature review, interviewing people, etc. And number two, they said it's great because it avoids bias, because humans are always biased, and so allows me to really structure a decision in an unbiased way. And the problem is precisely that being biased means that we are irrationally inclined to discriminate, to a way of thinking, because it's part of our culture. And so avoiding prejudice means simply following our cultural standards. And because AI has to be trained, it's impossible for AI not to be biased, because what we think is fair in our culture is biased in another culture, and what is accepted in another culture about gender, class, race is biased here. So it's really a tricky problem. I think Ashraf mentioned that. I think that's the main problem when we talk about ethical. It's a very limited concept. It will always be biased. We're all biased, except that what is the accepted bias here and the unaccepted bias over there.
Thank you, Enrique. Ken?
Yeah, I mean, maybe let me give you a more practical example. In terms of what I'm talking about here, we've spent a year exploring what an AI can and can't do. Bias is obviously a major part of that. So one of the tests that we ran was we created scenarios which represented the real world. One of those scenarios was a scenario for a man and a scenario for a woman. And our AI said, for the man, you got a positive reaction. For the woman, it gave us a negative reaction. What was interesting was it actually told us that there was bias in its answer. And when we interrogated it further, it said, when we build our method statements, which we'll talk about tomorrow, it would allow for that kind of hidden bias. And that hidden bias came from the fact that what it had learnt from came from the whole world, and the whole world tended to view women in business, in this business scenario, in a more negative way than they did men in that business scenario. So that for us was a very practical thing. And that was the beginning of where we started to design in how we cope with bias, because we're dealing with audits. It's all about opinions and judgments. So I think the AIs, certainly the AI that we've been working with, has actually got to the point where really it's more about the humans who are driving it than it is about hidden biases within the machine.
Thank you, Ken.
Okay.
Somebody want to add something? Yes, Luis.
Okay, so I'm going to be a little in a more practical setting, rather than talking about just bias in general, we have done some experimentation using different AIs, so let's call it AIs in general, and discovered that when you start asking questions, in our case was, for example, about gun control laws. And when you start asking a question initially, you say, what are the laws in a particular country? We did that for every country, by the way, in 195 in the world, trying to say countries who have more restrictive laws will probably should have less violent deaths with weapons, right? You will suspect that that's what you think is going to happen, but actually it's not. I'm just giving you the kind of some of the results we got. But my question is, my comment was about, we structured the problem by asking them, tell us what are the criteria to decide what means by restricting laws and ownership and all sorts of other things, right? And based on those criteria provided by the AI, in this case, we started using ChatGPT, but it cut that off because we're not paying anything. So it only gave us a certain amount of time. So we didn't want to pay anything. I would have been cheap at this time. So we used Gemini, and Gemini let us use everything at that time. And so what happens is that the moment you structure the question, we say, well, okay, given these criteria, can you tell me how restrictive are the laws for firearms in a particular country? And it turns out that as you keep asking the questions, the AI structures the answer based on what it learned before. And there's no, it doesn't come up with anything surprising. So now it becomes the human being who has to interpret what the answer was. So there was no machine that took that answer and gave you a scale 1 through 9. Tell me how restrictive you think it is, right? And so that's when we as human beings come in. And so Marcel was one person looking at it. I was another person looking at the same information. And we came out with different ratings in terms of the restrictions, how restricted the laws were. So now the issue is how, if you yourself are conditioned by what you read and how you interpret it, the AIs are not really they are not really, I would say, I would say synthesizing, that's not the word, is they're not processing mentally, right? The information they have. They don't have a soul. I keep saying that because I think that the difference between the machines and humans is that we have something else which the machines don't have, which is that what I call a soul, because I don't know what to call it. So the question is that would the machine ever, and I'm not sure exactly how they are programmed. I mean, there are different logics to use, right? If you definitely have to be a nonlinear logic. It cannot be linear, because otherwise everything would be always consistent, right? But we know that it's not true, that sometimes they come out with crazy answers so in terms of, I'm not talking about just bias, it's about how did they interpret themselves. If you ask the same questions over and over, they think that the repetition and the answers is just fine. But actually it's the interpretation of that answer that's important. So I have not fed the AI the answer it provided me before and say, can you tell me now, define a scale for me, for example, in terms of how restrictive it is in terms of ownership, owning laws to prevent ownership, for example, right? It doesn't give you that, because sometimes it answers you one thing and sometimes it answers different questions, different numbers. So the question is, because they cannot process it, they can only, Marcel was it, in my opinion, I think it regurgitates the information and then it puts it together based on some prioritization within the model, the neural net that they use right now. That's the language models, right? I'm sure there are other ways of looking at approaching it. Right now we are using LLMs, but that's not the only solution, obviously, because there are many examples which show you that they only come up with the information they have. So, for example, my first exposure to AI it was a medical informatics conference in which somebody came around and said they had this very sophisticated method to actually retrieve documents about concepts medicine. And when somebody said in the audience, tell me something of what is the causes of hypertension? It was 1992, 93. And the system couldn't have an answer. Couldn't say what's it. In fact, we know today that we do not know the causes of hypertension. And so even today, 20 years later or 30 years later, so how is the machine going to be? It's going to be biased whatever we fed it. It's our own bias, right? That's the way I perceive it. So if you want to make it unbiased, means it has to be in a consistent logic, which is always transitive. But notice that the HP is not transitive, right? You have rank reversal if you use. You don't have to satisfy some consistency. That's the whole argument that Tom Sardi had, was that if you are consistent all the time, then you cannot create anything new, because everything has to be consistent with itself, right? So you have to be a little inconsistent. But a little inconsistent means that sometimes you have to reverse yourself. And machines might not reverse themselves, right? We discovered that that's not going to be the case because they are programmed certain ways. So that's what I'm thinking about in terms of, I'm not sure that we have the capabilities yet to develop a machine that creates our own brains in there, because our brain is different than the machine. It's not just because it's a network. It's the network creating fields. Those fields are created by the neurons and the movement of chemistry or whatever. And that's quite different than the machines, the zeros and ones that we have right now. Maybe the quantum computer will be similar, but I'm not sure. So if Tom were here, he and I work on all these brain papers that we were trying to emulate a little bit how we make decisions. And we can replicate data. The problem is, can you create something new? And that is where the bias problem comes. That's my take of it.
Luisa, and I'm glad you brought that up. I was thinking about our firearms books as we were talking about this, and you may recall as well, we asked the LLM whether it valued A more than B and by to what extent, and it gave us a number, say 7, and then we asked it if it valued B more than A, and it couldn't give us the reciprocal right now. So this is part of the problems that we're having. The way that the models are built, it's a stochastic probability, and so it's trying to estimate what it is that it thinks we want it to return, and whatever we put first is what it's going to prioritize right now.
But Ken has a very interesting talk we should listen to, because he has built a system which actually, because it's actually allowed, it taught the AI that it can do pair comparisons in the reciprocal fashion. Okay, so if you put it into it, so the question is it consistently giving you the same answer when you ask the same question for the same problem? Is that, I don't know. So I'm looking forward to Ken's talk.
Alessio, can I speak?
Yes, Pearson, of course.
My experience with AI recently are very pleasant, actually. I know AI cannot answer mathematics. It doesn't know. It answers, but it gives the wrong answer. But the other day, I wanted to compare some criteria. So I just said some factors. I say, which factor is more influential on certain things? And he answered me. I say he because I'm just communicating with him, right? I'm communicating with you. And he told me, or she told me, actually, yes, one factor is strongly more important, but he said it is better if you use AMP to do these comparisons. I did not mention anything about AMP, but quite probably my previous interaction with him, he knew that, or she knew that I'm working on AMP, and that was his answer or her answer. I was quite astonished. I wasn't expecting.
Thank you, Pearson. I have one question to Elena. You work in creative decisions with super decision. Are you planning to introduce some artificial intelligence tool into software?
Actually, we are working right now. We have a free open source Python HPNP library for a little bit faster development. And we're trying to set up a chatbot that will assist in decision making using AHP and ANP. So essentially, by interacting with the chatbot, you would be able to be guided through the decision making process. And the second part of it, that kind of early. I mean, I would expect it at least not earlier than summer. But the second part is adding in the Python library, just because it's an easier interaction and addition, capabilities of getting suggestions for the criteria and the structuring. Meaning, based on what you have so far done, you could add this criteria, or based on what you have structured so far, you better go for a ratings model because you have 15 alternatives. Essentially assisting you through the process, but not giving judgment. At least the part that I have tested with the judgment making is not very promising at this point of time.
Okay, thank you, Elena. I think it's time that we wrap up. So what I hear is artificial intelligence is here for a long time. Artificial intelligence will help us to take decision. It can be complementary to artificial intelligence, or the other way around. AHP can be complementary to artificial intelligence in building the model. But what I heard as well is that the model is still built by a human. So the human is still the person at the top who decides which model we set, which criteria, which preferences. So human is still a large role to play on it. And as well, I hear that artificial intelligence is still far away to be perfect. So we still have some research to do to improve artificial intelligence, how decisions are taken. I will thank Luis. You want to add something? Yes.
Yeah, so Tom said he was thinking at one point that I think Ashraf, I think you might have mentioned that if you have many examples of hierarchies used in different disciplines, and you put it all together in the big dictionary, the famous encyclicon that he was putting together. But there is one. The only thing that there has not been addressed is that how you had to take all those examples and you had to put it to live in the same world. But that means if you look at the way the programming these days is, you have one hierarchy and you have one, and it's not the same as like opening the software into different versions. Is you need to have all the items, all the examples living in the same environment so they can interact. That means that you have to use object programming.
Yes.
So, that's right. So now that's a way. And then you can, if you are able to teach the AI that all those objects can relate to each other, then you have to design what does the object represent, right? You have a hierarchy as an object. In fact, Tom and I actually applied for a grant in NSF many years ago at the very beginning of the whole thing, that we were going to do exactly that. We were out of field. I think we were too early in the story, but they never gave it to us. And they said, "Oh, you're actually crazy. You can't do that." But that's not true, because if you take, for example, super decision, instead of programming as a single example running in itself, you have two examples running at the same time. That's what I mean by an object. So
yes.
like an agent. Agents interact, right? People don't do that kind of programming. You need to have the imagination to do that. And the question is, how consistent are the examples, right? Because there may be some inconsistencies that they don't have to reconcile. So how do you reconcile that? That is what I think the next step is in terms of AI and AHP. But I don't see many people working on that, because not only is it difficult, the question is, how do you create? We have the examples. The question is, who's going to write all those models? Who's going to write the objects? I mean, you may use frames, for example. I used to program in Lisp for that, But that's what I'm thinking, that you give me the idea that I used to think in those terms and I got away from it. But now that you mention it, it reminded me of.
If I can quickly, Alessio, can you allow me to speak for a while to respond to Luis on that? I think with the generative AI and the deep learning, it's actually about the context of the decision. So the idea of deep learning is that we are adding more layers in terms of the features or the context. And this is what Luis is rightly saying, is that it's the context of the decision itself. But the AIs are currently, with the current development of the generative AI, they are becoming very creative. I mean, I have seen AIs which can produce very nice pieces of music, poetry, artistic things, even programming. We set them a program to do, and they give us the code for the programming, which is the generative AI. But the unit of assessment of AI is not the sentence; it's actually words. So, for example, let me just give you a quick example. That when you are sending a message, I'm sending a message to my wife saying, "I am sorry." It will continue to tell me based on the previous message saying I'm not coming today because I am in work, for example, because it has seen what I have seen before, what I have said before as the messages. But the generative AI is not just taking what I have said before, but the whole World Wide Web. So it has vast, and this is what the generative, the idea of generative aspect of the AI. So I think in the future, the creativity comes in asking the right questions. It's not finding the answers. So how do you ask the right question? This is really where the innovation is, but the answer is already there. So that's why even when we, for example, penalize our students for using AI, we shouldn't, because the answer is there. So we should embrace it by maybe asking the students to ask the right question. And this is what in the future, what we should be, we should embrace AI rather than shy away from it. Like the calculators, for example.
It is what I was going to say, Ashraf. We should know how to ask the good questions, too.
Yes, it is how to make good assumptions and make good assumptions as well.
Yeah.
I think this is where things.
And we will be cautious that there can be some mistakes, but
yeah. Thank you very much.
I will finish to thank Marcel, Ashraf, and Elena for having this panel, and of course I need to thank Monica for organizing everything.
Thank you very much, Alessio. Thank you very much. Nice to see everybody from all times. Thank you very much.
Laura, what are we going to do?
Thank you so much. Well done for the presentation.
Thank you.
So now we are going to breakout sessions, I guess.
Actually, there is a break for
doesn't it start until 9:45?
We have a break? Oh, this is very good. Where is the coffee?
We're preparing it, Birsen. Thank you very much for all your insightful comments. And I think it has been a very interesting debate. All of us, especially those that are those of us who are related to teaching, we are very much aware of the latest developments because we try to introduce AI in our daily work as teachers, but we try to introduce our students also with that. I always say, well, that's my first year doing that, but I tell my students everything could be done with ChatGPT. As Elena always says, that Elena says that we have an assistant with ChatGPT, and that's it. So I think that if the seniors do have an assistant, they also may have this assistant. So the thing is that then how do we correct what they do, the students, if they have used the ChatGPT or Gemini or whatever? This is the second question. How can we correct? How can we assess these works that have been created with artificial intelligence? But that's a second thought. I mean, we're dealing with that, but I think they should use it. And you can tell the students that are good or bad the way they prompt the artificial intelligence. That's very easy to detect.
But Monica, I encourage my students to actually use whatever the AI they want to.
Yeah, whatever the AI. Yeah.
But to answer the questions from my quizzes, for example, although they probably don't have enough time to do it, it's only give them 10 minutes for 10 questions. I don't think they can put it into the computer that quickly. But nonetheless, if they could, I had a student coming the other day to me saying, I have these answers from the from the system, from the AI, and they're wrong.
They have to.
So who's wrong? Who's wrong? The AI or you? Me? Well,
No, I always say I'm not
correcting it,
wrong.
right?
Yeah, that's
And
right.
it was
That's
the
right.
AI that was wrong. So it's about interpretation. So, for example, very simple question was: is overbooking an important problem in theatrical shows and for theaters?
Theaters.
Theater
Okay,
industry.
yeah.
The question is, the AI said it was very important, but actually it's not important because you don't do overbooking in theater.
No, they don't do. They do it in the flights, but not in theaters.
Right.
That's
So
it. That's
you
it.
see, but the AI thought that because they don't do it, it's very, very important not to do it.
Oh, yeah, I see. Yeah.
See what I mean? The interpretation. So
Yeah.
I'm sure in a different language, not English, right? It would be maybe different.
Yeah.
See
You're
what I'm
right.
saying? But in this particular case, they didn't get it right because, and I understand how the AI thought. I'm thinking, of course, if you don't do it, it must be very important. You don't want to do it. So
So
how
that's the
do
way
they
you
know
say,
it's right? They don't know. You see, that's the problem. You have to actually read the book before that, but sometimes it's not there.
Well, actually, it is a little bit about the way that you set up the prompts, Luis. If you know how to ask the question in order to have a very algorithmic structure and you know how it works behind the scene, you can make it answer to you correctly. And I say it from the decision tech students, which I allow just in math-based, essentially, courses to use ChatGPT until they plead that they don't want to use it. You don't use an LLM in order to solve math and expect it to be better than you, essentially.
Well, but it's
even
that's not its job.
Elena, it gives the wrong answer. You ask again, it gives another wrong answer. So I stopped. Yeah.
I show them always in the project management class. I ask ChatGPT about how to do the calculation of the critical path. There is no chance that it will manage the first time to give the correct answer.
Even simple probabilistic problems, it starts asking you questions to try to answer. And as you proceed to giving that question, the final question is to give you the answer, it asks you the question you're asking.
It's like you're wondering why the TV is not doing math for you.
Right.
It's not its job, really. It is not made for that purpose.
Wait, but that's not, that's not entirely, it's because that the language models are not prepared for that. But you could have a system that actually will give you the answer.
Yes, but it wouldn't be this system that they are trying to use right now.
The intention they had there wasn't to create an answer for mathematical problems.
Exactly.
But look at for example, they have been, look at the Nobel Prizes in chemistry and physics, right? You see them? They are people related to using these models because of searches. They're searching for combinations of molecules or whatever it is they're searching, and it has more variety. So, for example, if you ask them to, how many colors do you need to color a map? Minimum number of colors. But the 4-color problem tells you it's 4, right? But if you ask them to prove it, the proof is 40 pages long. And they use the mathematicians to solve it, use a computer to create all the possibilities, so to speak, all different types of graphs that you could have. But for a long, long time, mathematicians didn't recognize that as an answer because they were using computers. So it's, in fact, Tom wrote a book about the 4-color problem, right?
Yes.
Yeah, and one of his students is the one who solved the problem, that I correctly recall. So you have to be able to know how to generate these models mathematically. So you have to create a structure that represents the math, the concept. And that's not what they're doing. They're only using words right now. Different weights on the weights. They arrange in different ways that are consistent with their logic, so to speak. That's the way I generally look at it. When I was in
the
the
other models, however, are there, Luis. It's just that they are not ChatGPT that everybody goes and uses because it's not made for that at all.
I know. And so when I was in the last AI conference, I was in New York in 2020, just before the the pandemic, there was one of the older professors in the AI, I can't remember his name now, he was well known, gave an example of why AI today is not what AI is about. AI, they had it was a graphic, it was a center in soccer and a goaltender, and the circle came through the field and every time passed the goalie and he scored. But then they discovered that if the goalie came out and shook the right leg, shook it like that, then the center couldn't score. So that means that there was a hole in the system, right? Yeah. Because you don't have all the rules there. So when do you know you have all the necessary information to make the right decision? You don't, never. The continuing hypothesis, right? So you can have all the data you want. You'll never know exactly if you made the right decision. It's almost an impossibility. So who's going to solve that problem? So that's the reason I'm a little skeptical sometimes when people say, oh, we have this very, very complicated system with all this information. We have to be making the right decision because we have all the information available. But there may be a hole somewhere. And that hole in the logic is what makes the wrong decision.
And most of the times, the data interpretation is more important than the data that you collect, meaning that you can make huge mistakes just because, I could culturally prefer to use positive words to describe how much I'm in pain or not in a medical system. And culturally, somebody else use always mild words, and everything will be completely wrong at the end of the day because we don't know what we are talking about. And that's kind of the problem that we are here. The systems are there.
I mean, Claudio knows in medical diagnosis, right, that there was a diagnostician here by the name Jack Meyer. Jack Meyer was modeled by a computer called Caduceus or Internet 2, or whatever the name was at the time. And it was funded by the NIH for many years. And the system worked well when the person who was the expert, so to speak, Jack Meyer, used it because he knew what questions to ask. But when a neophyte, the person who didn't have much knowledge, used it for diagnosis, they discovered very quickly that if you keep asking for more tests to find out what the patient has, given the symptoms, you may end up killing the patient. So I don't know if you guys read about using AI systems in medicine. So they have shown that the ChatGPT programmed for doing this kind of diagnosis for 6 cases that they had, which have not been published before. So the system didn't know anything about it. The system scored higher. The guy higher scored than 105 physicians. So that's a paper that was published in the New York Times, noting that that's exact. So how is it that in this case was ChatGPT 4, whatever the version was, that they scored about 90% on the 6 cases that they showed the system. The same cases were shown to the physicians, and the physicians only score about 76% accuracy.
And the question there is, those physicians, how do they score compared to the rest of the physicians?
Well, and they also allow the physicians to use the system, by the way. And they refused to accept what the system was telling them because they didn't believe it. So that's the reason why
that's
they score
very
less.
interesting, yes.
See what I'm saying? So
yeah.
They thought they were the experts, and the experts said, no, I don't believe that. That information is wrong. So it turns out to be is the same question that you would say, how do you know how certain you are that you are right when you make a certain decision? And it turns out to be that in real life, it turns to be that the person who says this most sure that is correct is usually the most wrong. And that happens all the time in all sorts of decisions, especially in public life. For example, Jimmy Carter sent the people to Iran to rescue the hostages, right? And all the experts were saying, oh, yes, definitely we're going to get them. And they were all wrong. So how do you cope with that? How do you make sure that that's I don't know how to answer that question, but
I think that the question is, do we need to care about it?
Oops.
When you go to the doctor, they might make a mistake. When you drive the car, you most certainly will make a mistake, or I will, you know. Why your AI should be that perfect? That's the kind of the question of the day. Why do you expect that the AI will be better than what would you be?
Well, for certain tasks, you might, right? Because it has the speed, maybe the speed of the reasoning, maybe.
It might. I agree on that it might, but do I need to take it, you know, like a huge mistake if it's not better than a human?
Well, think about the concept of common sense, right? A little child has more common sense than a computer. So anything that is called common sense, computers fail to capture it, because they don't have a soul. I'm telling you, that's what my take of it is. It has to be something.
I think that's
I mean, look, Louis knows a little bit about what we've been doing. And I'm just trying to think of the best way to kind of describe this thing. One of the things that has been interesting for me personally is I'm not a computer programmer. I can think logically, I can give structure to things, but I can't get my head around that way of imagining items. So about halfway through our project, we got to the point where I actually stopped trying to design what the AI should do. I got the AI to design itself. And it was very effective at designing what it wanted to do to achieve the job, to create the solution that we wanted, which was mostly to do with testing and trying ideas and exploring. And I think through all of this, there is, I would say, I now believe that AIs, we can't use AIs the way that we have classically used computer tools. I actually don't think it's going to work. I think it's going to create so many ethical dead ends and so many problems and so many mistakes and errors. I think we have got to kind of teach ourselves to look at this new world of using AI in a different way. And we'll find out soon whether, with what I'm going to present, whether people will agree with this kind of view that's emerged over really the last year of some quite intensive playing around and experimenting and just trying different things, because we had no base to start from. We had no history, no baggage, no legacy. We were just playing. So that, I think we have to look at this from a completely different viewpoint. I mean, I call it autism. We have to think of AI as being autistic. So we have to talk to it like it's autistic. So that means we have to understand autism and what that might mean to an autistic person. So I mean, I'm coming back to this group, if you like, and the discussion is really interesting because I can already sense that there are people who are kind of trying to reconcile the legacy and the history with actually something that maybe doesn't quite fit, but we don't quite know what that thing is going to be that fits. So I think we are really at a point of something quite different, and that's good different or bad different. How humans use it is entirely up to humans. So that would be my view really in kind of where we've got to.
Thank you. May I add a little bit? As we are working with decision mentor, we'll be talking more on Sunday, but we are learning a lot. What we would like to call is augmented intelligence, not fully artificial intelligence, but human intelligence combined with artificial intelligence. What AI helped to decision mentor. Earlier, the brainstorming session, you have to identify the criteria. Now we have API with OpenAI that recommends the criteria. Earlier, first version of decision mentor, the people at the ground were struggling to identify criteria. Now they are happy that at least they're getting recommendation, but they have option to edit, accept or not accept those criteria. So when decision needs human brain, then but automated decisions, I think is a lot of artificial intelligence may work, but when the human brain needs to use, I think it will be augmented intelligence in the days to come. That's what we are feeling. We are feeling, and we have writing a book chapter published, analyzed 50 publicly shared decision in the decision mentor app. So there's how AI added value. That also we have analyzed. Thank you very much. More we will be talking on Sunday. Thank you. That's what I wanted to add.
Okay, thank you, Shashi.
So this has all had me thinking about this company. I think it's in Canada, if I remember right. D-Wave. So they have a computer that they claim is doing quantum computations, and physicists are feeding data into this machine that is predicting astronomical events and is extremely accurate. But the problem that the physicists have is they don't know why, right? They don't understand. So if we ask a computer a question and it gives us answers, if we don't have understanding, this is getting back to Luis's point, right? The computer doesn't have the soul, and we don't know if the criteria it's giving us are right or wrong, right? We have no understanding of why it's producing this. Then what do we do with it, right? And this is the same problem I see even my students making. They feed a question into a machine, the machine gives it an answer, and the student has no understanding of the answer, and the students submit the answer to me, and it doesn't address the question because the students don't know. And this is part of the problem that I'm currently having. Great, D-Wave is doing quantum computations, but I have no understanding of the results that it gives me. So what do I do with it, right? Do I just accept it or do I dismiss it?
Yeah, it's interesting going on. In decision mentor, if any of you have tried, the writing a decision problem itself is the prompting to a AI. Because the AI recommends the criteria that how properly you could write the decision question or decision problem. That's why the value of prompt engineering is coming up. Thank you. That's what I wanted to add.
Roseanne, you're muted.
Mute. Thank you, Monica. Yes, I'd just like to say something. I'm very proud of all of you. I'm amazed at how different the use of AHP and ANP has been in the last 30, 40 years. It used to be all technical and boxed, and it was just a very engineering kind of thing. Now people are talking about ethics, you're expanding, you're also intelligent. I'm very impressed. Thank you for the contributions that you've made to this discussion.